Okay, so this is January 2016, paper number 1. This is question number 7. Scientists use the term radiation in different ways. So it can be used as either particles or high frequency waves. So we're going to draw a line. If it's electromagnetic waves, is this alpha, beta, gamma, or is it a neutron? What type of radiation is it? Well, you've never learned about neutron type of radiation, so that takes that one out. So electromagnetic waves, you should know that that is gamma. Particles with a negative charge, that is our beta. Particles with a positive charge, that is our alpha. This is a helium nucleus, 4-2. So it's made out of 2 protons, 2 neutrons. So that gives it a charge of +2. This is just made out of an electron, which is -1 charge, and this is just a wave. Alpha, beta, gamma radiations are described as ionizing. So we're going to complete this table. Which is the least ionizing radiation? That's gamma. Which is the most ionizing? Alpha. And then right in the middle there, it's going to be our beta. So could we have swapped that round? So if it said least penetrating, well, that would have swapped this round, and alpha would have been here. Most penetrating, that would have been gamma. So because alpha is the least penetrating, it is the most ionizing. If you need to go and look that up, go and look that up in the textbook or in the lessons online. Describe 2 ways in which these ionizing radiations can be cause harm. This one's pretty straightforward. You can say it's damaged cells. You could say mutations. That would have got you the 2 marks, and the other one would have been can cause cancers as well. Something like that. You could have had kills tissue, cells, radiation burns, radiation poisoning, changing genes. There was a lot you could have said here in order to get those 2 marks. Okay, this one, it looks complicated, but actually is pretty straightforward. So all it's saying is they've got this badge and there's some photographic film behind it. And if radiation goes through any of these absorber windows, you can tell which type of radiation it is by what's discolored on the film. Because each absorber window is made from different thicknesses of paper. Notice you've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So for the first one, what we're gonna do is use the words go through or stopped. So alpha radiation, is it stopped by 0.1 centimeters of paper? Well, yes, it is. So that one is stopped. It's stopped by paper. It's stopped by any thin paper. But radiation, beta radiation, goes through. Okay, so we know that here, if there's nothing here, then alpha was coming through there, and there's nothing showing up because it's been stopped. Here, beta goes through. So alpha radiation, is it stopped by 0.5 centimeters of aluminium? Yes, it is. Gamma, that just goes through. Goes through anything. But beta is stopped by 0.5 centimeters of aluminium, so this one, definitely 0.5 centimeters of lead is going to stop it. But gamma rays still go through the lead. They're only reduced by very thick lead, so they're never stopped. State the name of another device that can be used to detect alpha radiation. The one that you know is a GM or a Geiger-Müller tube. The other ones you could have said are a cloud chamber, a spark chamber, or for those who are really into nuclear physics, a semiconductor detector. But the one that we know, and the one that you should be able to write down, is a Geiger-Müller tube. Okay, that's question number 7.